Eyes up here. Everybody's watching. Zach is watching. Here we go. Gentlemen. Andy, let me just get it. It's really fast. We're having more than one thing happen at a time tonight, right? We're going to be making more than one decision. We might be making a decision on 2 things or 3 things or 4 things. And how do we do that? So the first thing that we need to talk about, and you might want to just use your pencil to circle it, when we have compound events, it means that we got more things happening, more decisions to make, right? That's all we're talking about. Simple is one decision, compound is more than one decision. And when you make decisions, there are 2 options. Option 1 is a thing called independent events. And independent events means what I decide in the first decision has no impact on the second decision. And let me give you an example of that. That I am going to decide to roll the dice. We're playing pig. And I roll a 4. And then I'm going to roll the dice a second time. The dice have no memory. They're not like, oh, you rolled a 4 last time. I'm going to trick you and roll something else. Each roll has no impact on the roll before it, right? So sometimes we're going to say, oh, what's the probability that I'm going to eat tacos tonight? And what's the probability that I will wear these tennis shoes tomorrow? The tacos and the tennis shoes don't impact each other. They're completely separate things. When things are completely separate, the way we do probability is really easy. We do the probability of the first thing happening, and we times it by the probability of the second thing happening. Can we do many things? Yes. What if I wanted to know what's the probability of me eating tacos, wearing these tennis shoes, and calling my husband who is at the cabinet, right? Then I can have another probability. I just keep timesing, right? So if they don't impact each other, it's really straightforward. Probability of one times the probability of the other, multiply them together, done. Now, sometimes things impact each other. So let me give you an example of that. I have decided to randomly draw a name, 2 names out of a hat in this class. And I have decided I'm going to give each of those students $1,000. Yay. Put your name in the hat, shake it all up, reach in, I pull out Andre. Everyone is very excited about that. Yay for him. It would be crappy if I dropped his name back in, shook him up and pulled him and he got the other 2,000, right? What would be better is if I pulled him out and now he's not part of it and then I redraw again. But when I do that, it changes everything, right? Because now he's not part of the second drawing. Does that make sense? So if I do 2 things and the first one affects the second one, they're called dependent. So here's what it does. You find the probability of the first one, you times it by the probability of the second after the first has messed with it, right? That's my Mrs. Tarantino way, mess with it, right? So when we do these tonight and they're dependent, what I do the first time is going to change what I do the second time. It sounds weird when we do these. You're going to be like, oh my God, so easy, so easy. Okay, let's start with independent ones because they're the easiest ones. Nice and easy. Here we go. First thing, here we go. We got some dice. And you know when we play pig, I don't start on a 1, right? Because I don't want to start on a 1. It makes the game no fun. So I'm sitting here with you guys. I take the dice. I roll it. I shake it. I roll a 1, right? Let's talk about the probability of rolling a 1 one time. How many sides are on the dice? 6. How many 1s are on the dice? 1. Yay. And I'm like, let's do it. I rolled a 1. I'm going to roll again. What is the probability that I roll a 1 again? Guess what? 1 over 6. Oh, I'm not feeling great about this. But I'm going to roll one last time. What are the chances I'm going to get 3 rolls of 1? Yeah, not very much probability. 1 out of 216. Does it happen? It does. We've seen it happen, right? Where it's like 1. Oh my God, I keep rolling a 1. But I wouldn't bet on it, because let's change that into percentages, because I like it as a percentage, and it's not even 1%. It's about 0.0. It's about 0.5%. It's like a 0.5% chance. Rolling 3 ones in a row, really unusual. It happens though. So I'd like you to try the next one. We're doing 2 things. We're flipping a coin, and we're picking days of the week out of a basket. They are separate. The coin does not affect the days of the week. Do this next one. Give it a try.
Just wash this for toast.
But I also don't have to kill you.
You can understand the you don't know Uncle Vincent, but Uncle Vincent is bad.
What'd you get? I think I offered to, and no one wanted it. I think you guys were like, no, I don't think this is a great CD. Well, but it is better because you can see the That sucks. I don't know why. You know what? I know why. Because it went away slowly. Remember, I lost kids over the course of the semester. Right? Second semester, I started with, there was a couple kids in here, and then they just slowly, they switched schools. And kids, and so, I will explain later. Yeah. Okay, so here we go. Coin is tossed. I only have heads or tails. Those are my only choices. I want tails, 1 out of 2. Now I'm going to do days of the week. Well, there's only 7. I had someone in my other class go 5, and I thought, you're an idiot, but you're pretty. Tuesday, Thursday. Those are the only 2. There you go. So here's what I'm going to get. I'm going to get 2 over 14, but you know me. I don't think that's usable. I want to make that into a percentage because I think it means more to us as humans. 2 divided by 14, about 14% chance. That's not bad. I mean, it's not great. It's all history. Yes. Because there's 2 days that start with a T, a Tuesday or a Thursday, and there are 7 days of the week.
I see 1 divided by
1 divided by 60 is 0.004, and I don't it's 0.0.
Got hella ice cubes.
Okay, let's try this next one. I love this next one. Now, the next thing I need to do is I need to watch you with a specific word here. The word that we're going to look for is the word replace. And here's what's happening. So a crayon is selected, and then it is, look at this. I want you to underline this. I want you on your notes to underline that word replace. Because what replace does is it keeps it independent. Here's what I'm doing. I have a basket of crayons. I am reaching in. I am grabbing one out. I'm writing up, I'm coloring my little thing, and then I am putting the crayon back in. So when I go to draw again, nothing has changed, right? If I took that crayon and I set it aside, it would change things, but I'm not, I'm replacing it. So the one thing I want you to write on your notes right now, put by the word replace, that keeps it independent. Each draw is separate. They don't impact each other because you're putting it back in. That would be like if I drew Andre, put him back in and drew him again. That's independent. Yay for him, he gets the $2,000, right? So let's do this first one. Here we go. We are picking 2 crayons. That's 2 decisions. 1, 2. How many crayons total are in my basket? Add them up with your neighbors. Nice, nice. There are 32. I would like to start by picking a purple. How many options do I have for purple? 14. I put that one back in. So I'm still at 32 crayons. That hasn't changed, right? I'm still at 32. Yay for me, but now I want a yellow one. I don't have as many to choose from. Looks like I only have 6. Now, I want to talk to everyone. Get your calculators out. You ready? Here's how I would do this on my calculator. Here's where you want to be careful. I would do this. I'd multiply across. I would go 14 times 6, hit enter, and then I would hit divide. And what I'm going to do in my head is 32 times 32. But if you just push in 32 times 32, your calculator thinks you think you're doing this. 32 times 32 on the bottom. Your calculator is going to do this, and then it's going to stick the 32 up on the top. So what you want to do, if you want to be lazy like me and do this problem quickly, please do me a favor, throw parentheses around it. That gets you straight to the decimal, to the percentage. Do the math now so I all know that you know how to do it. Are you ready? Here we go. Push some numbers in. 14 times 6 divided by parentheses 32 times 32. Your calculator, when you divide, needs you to be very specific, or else it's going to pop that 32 up to the top. So I got about 8%. Are we feeling it? Talk to me, Thomas.
Could you also do 14 times 6 divided by 32 squared?
Yep, perfect, perfect, perfect. And your calculator is going to be okay with that because it knows that the squared order of operations goes like this. But that's why we need the parentheses, because it's called the ambiguous case. It means, do you mean divide on the bottom, or do you mean times on the top? And since your calculator doesn't know what you mean, that's why it needs it. But the squared is perfect because your calculator knows, ooh, I do that first. Yeah. Love that, love that. Okay, could you please do number 16? 2 yellows. And Thomas, do this one tricky. You know what I would do? I would do 6 over 32 squared. But you don't have to. You can do it all sorts of ways. I got 6 over 32. I got another 6 over 32. So many ways to push that in your calculator. One way is like this. Or you can do 6 divided by 32 squared.
For the ones under this, are you putting the marbles back?
Yeah, no, that's what we're doing next. What'd you get for your percentage on that one? 3.5%? Like almost 4%, 3.5? Nice. Okay, so here's what. Let's do this next one. We're doing the same problem. We're doing almost the same problem. I got red, I got blue, I got green. But look at this. Here's what I need you to see. If I don't, gentlemen and ladies, if I don't say the word foul, replace, we don't assume we're replacing, right? So most of the time, it's without replacement, because I would say with replacement. So on this one, I am pulling a marble out, and I am not putting it back in. So let's just start by picking just one marble. That's our basic simple one. So here's what I have. I have 5 green, that's 8. I got 12 marbles. So here's what, 12 marbles, and I am picking red. That's 4 over 12. Nice and easy. So I'm going to show you 2 ways of doing this problem really quickly. 4 divided by 12. I'm going to get 33%. Not red. Guess what? I don't have to do any math. It's the opposite. And they always add up to 100%. So this has to be 67%. Does that make sense? So if red is 33%, not red is 67%. Okay, now we're gonna talk our way through this next one. Here we go. We are picking two, but I need everyone to watch this one because this time we're pulling one out and then dropping it over the side. We're not putting it back in. So the first thing is I have 12 marbles and I want the first one to be red. Yay for me. That's going to be 4 out of 12. Have I lost anyone? Now everyone's watching this because this is where it gets weird. I'm not throwing that marble back in. So now, how many are left in the bag? 11 and 3. Right. 3 red are left and 11 are left. The thing I picked before impacted the new one. Does that make sense? Is everybody cool on how dependent ones work? Once you pick that marble out, you don't put it back in the bag. So everything goes down, right? We're going to just do the last one. We're going to jump to it. We want no blue ones, and we're pulling 4 marbles. Are you ready? Let's go 1, 2, 3, 4. I have 12 to pick from. I don't want blue ones. So let's remind ourselves how many were blue. We had 3 blue. So that means 9 are good. Yay. I picked it. I got a yellow one. So now I'm down to 11, but I only have 8 good ones left to pick. And then I'm down to 10 and 7 and 9 and 6. Is everybody cool on how dependent works, right? Dependent, everything changes. Independent, they stay the same. That's it. I am done. Your homework is very easy. I did it. The lady who does the stuff I steal, put it in fractions. I did it in percentages. So if you want to take a picture of that, whoever threw food, look at that.
I got a lot of questions.
That is so fast. You'll finish before the end of the period. Oh, and the back one, number 4. Oh my God, what was I thinking? Cross it off. I wrote that. What the hell last night? I'm like, oh yeah, do that.
Hell,
No, don't do it. Cross it off. Cross it off. No, like cross off number 4.
I did.
Cross off number 4. Like what really, genuinely? What was like last night? That was a good choice. Yeah, that's a good choice. Cross off which one? Number 4. Yeah.
What's so funny, Colton? No.
Hey ladies, would you do me a favor? There are pens on these. Cross off number 4. Goodbye, people. I like it.